So, good morning, Year 10. It is Wednesday and we are looking at energy and work. This is lesson 3. So, you have a starter activity here. You have 6 questions in your books. Pause the video and answer these questions. So here are the answers. Check yours and make any corrections and see where you went wrong. The biggest one probably is number 3 about the Big Mac. Remember, food, petrol, crude oil, diesel, they are all chemical energy. So we are looking at work today and work and energy. We must remember that work is only done on an object when there is a force applied and it actually moves over a certain distance. You can actually apply a force to something and not actually move it. If it doesn't move, if it doesn't show any traveling distance, it is not work done. So what I want you to do here is I want you to write a definition for work done. So you probably worked out from the previous slide that if you've got 10 newtons, a force of 10 newtons, and it's moving a distance of 2 meters, the work done is going to be 20. Because it's energy, it is going to be measured in joules. So actually the formula for work done is force times by distance. What you'll notice here from this equation, that work done is W, and it is equal to F for force and S for distance. Be really careful with this one. People often make the mistake of thinking that that S actually represents seconds. It doesn't. The S actually represents distance, and distance is measured in meters. So what I want you to do, I want you to draw this triangle, the maths triangle in your book, and then I want you to work out the 3 equations that you can actually get from this maths triangle. So you've probably worked out that obviously we've got the one on the screen, which is work done is force times by distance, F times by S. You've then got force, which is work done divided by distance, so W over S. And then finally our distance, S, is equal to work done divided by force. So make sure you've got those 3 different equations because you are going to need them in a minute. So we're going to try some practice questions now. So you will need those 3 equations. Don't forget you need to show all your workings for maximum points. The equation you are using, first of all, obviously, the numbers then swapped into the equation, and then finally you need to show your answer including units. Do not forget the appropriate units. So I want you to now pause the video and you are going to answer these 6 questions. Look very carefully at the question. What are they asking you? Are they asking you for distance? Are they asking you for work done? Or are they asking you for force? It's very simple to look for what's being shown already. So if you've got newtons in the question already, they've given you a force. If they've got joules in the question, they've already shown you some detail for work done. If they're showing something in meters, they've given you the information for distance. If you eliminate what they've given you already, that will show you what they're actually asking for from the question. So pause the video and have a go at these 6 questions. So mark your own work. Don't forget we are looking for the equation used, the details of the numbers, and then finally the answer with units. There are 2 marks available for each question. 1 mark for your equation and workings, and then obviously 1 mark for your answer with units. If you've just got the answer with units in a GCSE, actually they would give you that as the full 2 marks. So for example, in the first question, if you've got 3 meters written down, you'd instantly get the 2 marks. However, if you've got the 3 meters wrong, but you've shown the appropriate equation and workings, you would still get a mark. So mark your own work. The first question was looking for distance. Second question was looking for force. Third question was looking for the work done. The fourth question was looking for distance. Fifth question, force. And finally, the 6th question was work done. Total is out of 12. As we go through our lessons over the next 5 or 6 weeks, I will be giving you tips here and there and things to take note of. So especially people that are aiming for high-level grades, you need to make a note of these. For example, here, make a note that no work is done if the object is not moving in the same direction. So for example, work is only done when the box is being lifted. When the guy is actually walking along with the box isn't actually moving. The man is moving. So at that point, no work is being done. So to get something moving, or equally to stop something moving, you need friction. So friction prevents an object from starting to move. So obviously we all know the brakes on a car or the brakes on your bike. So the middle picture here is the brakes on the bike. Actually use friction to stop something moving. And actually what you'll find is that movement energy, so kinetic energy, is actually transformed into something else. We know that energy cannot be destroyed or created. It is literally transformed. So in this case, energy, kinetic energy, is transformed into heat energy. Now you can actually prove this for yourself now by rubbing your hands together. As you rub your hands together in a different direction, that movement of energy, that kinetic energy, is transformed into heat energy, thermal energy. So when work is done to overcome friction, some of it is transferred into thermal energy that's stored by heating. So you can see this in a shooting star, for example. As that meteorite is actually flying through our atmosphere, it is actually moving through particles. And as it moves through those particles, that kinetic energy of movement, as it hits the particles, is transformed into heat energy, which is why we get that blazing trail of heat and light and sound that you can see from a meteorite in a shooting star. So, can you summarize the information on this page into 1 sentence? 2 at an absolute maximum. So pause the video and summarize this information about friction. So to finish off, I would like you now to pause the video and fill in the blanks in these 3 statements. This basically then covers the whole topic of energy and work. So pause the video and fill in the blanks. So year 10, well done. That actually brings us to the end of this lesson. So enjoy the rest of your day.